Q and R, two gears Q and R are compound gear, and number of teeth on P, Q, R, S is given as number of teeth on P is 20, number of teeth on bigger gear Q is given as 40, number of teeth on smaller gear is 15, number of teeth on S is given as 20. It is also supplied that the diameter of this bigger gear is twice of the diameter of R, that is Q, and the diameter of Q is given as twice of diameter of R. And second, module of this R is given as 2 mm. We have to find the distance, center distance between gear P and gear S. Okay. So now, what is given? First of all, given number of teeth and module is given to us. So module is given for gear number R. So we can find the diameter of R because module is given and number of teeth is also given. So we know diameter is equal to module multiply of number of teeth on that gear. So module is given as 2 and number of teeth is given as 15. So diameter of gear R is coming out to be 30 mm. Okay. So we also, one condition is supplied to us, that is a diameter of R is half of the diameter of Q. It means diameter of Q we can find easily twice of diameter of R. So it is twice multiply, it is 30, we have just find from here. So it is diameter of Q we can find from this one. So diameter of Q is coming out to be 60. 30 multiplied 2 is coming out to be 60 mm. So this two value we got it. From one is diameter for R and one is diameter for Q, is we got it. Now second thing, we have to find the diameter of P and S. So P and Q are in engagement. It means module of P, gear P is equal to module of gear Q, because they are in engagement. So module must be same for both the gears. So it means module, we know that diameter of P, number of teeth on P is equal to module for Q, diameter of Q, number of teeth on Q. So diameter of P we have to find, number of teeth on P is given to us, that is 20, is equal to number of teeth on diameter of Q we just find from here, 60 upon number of teeth on Q is given as 40. So it is coming out to be, diameter of P is coming out to be 30 mm. Now we also know that, so this Q and R in engagements, it means module of R must be same as module of S because they are in engagement. So module of R must be same as module of S. So module we know very well that module is equal to diameter, that is for R, number of teeth on R is equal to diameter for S, number of teeth on S. So diameter for R we just calculate from here, that is 30 divided upon number of teeth on R is given as 15 is equal to diameter of S we have to find divided by number of teeth on S, it is mentioned as 20. So diameter of S is coming out to be 40 mm. Okay. So we got all the diameters from here. So now P and Q are in engagements. So we can find the distance between P, center of gear P and Q. And Q and R, both gears are coaxial. It means we can find the distance from here to here, center distance between this P shaft and Q shaft. So and we can also find a distance between R shaft and S shaft. So we can add all the distance, we are getting the distance between P and Q. So it means we can say in different word. So distance between P and S is equal to radius of this one and radius of bigger gear. Radius of P plus radius of Q plus radius of this small that R gear plus radius of this S gear. Radius we know very well that diameter by 2. So it is diameter of P divided by 2 plus diameter of Q divided upon 2 plus diameter of R plus divided by 2, diameter of S divided by 2. We can take 2 common outside, 1 by 2. So diameter of P we have just find from these calculations, it is coming, we got 30. Diameter of Q we got earlier 60. So diameter of R from here, that is 30 plus diameter of S, that is 40. So if we add all the values, this becomes 60, 61, 21, 20 plus 40 coming out to 160. 160 divided upon 2 is coming out to be 80 mm. Now this kind of problem you can solve by, if they are looking for this, first of all this problem is coming from the compound gear. Okay, so the input shaft is P, this is your input shaft. If you're taking input shaft, it is give some rotation clockwise or anti-clockwise, and this S is anti-clockwise direction. It may be sorry, both axes P and Q are different axes, both are not coaxial. So it means this is compound gear and this is not reverted gear train, this compound gear train. So in case of compound gear train, so see the geometry first of all. Second thing, we can find one equation from speed ratio, or we can say train value, but they didn't ask any train value. So by geometry you can find the distance between here to here. If they are looking for the train value, then you have to go for a train value directly. So number of teeth for driven, product of number of teeth on driven divided by number of product of number of teeth on driver, that will be the speed ratio, or you can say that will be the train value. I hope this is very clear to everyone.